Good. There we go. All right. So to welcome everybody to the Lightning Talks, please give a round of applause for Kentaro-san.
Great. So I am Haraken. So welcome everyone to the BlinkOn Lightning Talk session. Are you excited? Yes, so thank you very much. So I am so excited and I got a party popper. So this is a mandatory item to kick off the Lightning Talk session. So all right, so let's celebrate. So 1, 2, 3, BlinkOn. Amazing. Okay, so today, so we have 15 lightning talks. And each lightning talk is 3 minutes long. So if you are a speaker, so please make sure to finish your amazing presentation in 3 minutes. So 3 minutes is the hard limit. And if you are joining remotely, so please send a heartwarming message to the speaker using the text chat and emoji. So I can show you one example. So I pasted one short JavaScript in the text chat. So can you see this one? So you can open DevTools and paste this JavaScript and hit enter. So then, so you can send a round of applause automatically. So this is convenient, so feel free to use this one. So I think we are now ready to start. So let's get started.
Thank you, Kentaro. Unpin. There we go. Already we're having fun over here. Okay, let's open up with open link, John Turpish. Let me just present this. Yep. Good morning. I'm here to talk about getting some IPFS functionality in Chromium. Can you hear me all right? All right. What is IPFS? It's content address networking. So that is verifiable content agnostic to the immediate network source. I like to use the analogy of where an HTTP URL tells you where from, an IPFS URL tells you what, and IPNS URL will tell you who. So there's 3 URL schemes we need to be concerned with here. The actual IPFS URL is immutable content that you verify with a hash that's embedded in that big ID right there. An IPNS URL is a mutable pointer to the immutable content, and it's verified through key signing. And then there's this convenience layer of DNS link that uses text records. Let's just try to get a feel for it here. So if the user entered this URL, this particular one has an IPNS name in it, so we're going to request its record. And it also, we're going to use the key that was in that URL to verify the record, and you can see the value there points to a DNS link in this case, which is contrived but legal. So we're going to do now we're going to the next step, which is a DNS lookup for the text record to get this link here. That particular one is pointing to IPFS, and now we have our immutable content. This is essentially the root of a Merkle tree. When we request that back, we get this record that actually has a protobuf in it. And in this case, it's a directory. And so it contains all these children, which are links with further CIDs to go downstream. Now, we didn't have a path in our URL, so we just landed on this directory. So we're going to request index.html. This particular file it's less than a megabyte, so it fits all in one block. So we have the entire file, we render it. That particular HTML file has an image tag in it, so we're going to make a separate request for that. Now, lucky for us, we have all this stuff in cache. So we don't have to repeat all those steps that I mentioned before, from kind of going left to right on the URL. So instead, we're going to request that NUXT directory, which is the very next element of the path we don't have. You might notice all these HTTP URLs going up at the top here. These are requests to the gateways to get the different pieces I'm talking about. That directory has the image we're looking for, so we're going to use that. Now, each of these IPFS URLs are getting verified by hashes. We only started with the hash to the root, but each element contains the hash for the next. If this file happened to be very large, multi-megabytes, instead of being a single block as a file, single block would be the root of a tree. And so then we'd start requesting these file parts. Shucks. Thanks.
Very much. Next up is Steve Cobes. Here you go, Steve.
Thanks, Ted. Hi. So I talked about scroll unification at a previous BlinkOn, actually. But in case you weren't there, it's this giant refactoring project to handle all gesture scroll events on the compositor thread, because we had these two different threads, right? And they each had their own implementation of scrolling. But after unification, all these events are only handled over here and not over there. So all of this code goes away, and we get rid of the redundancy in the architecture. So what's new compared to last time? Well, the big news is we shipped. Yeah. Thank you. Also, we unshipped because there are some bugs. Then we reshipped by accident. Then we unshipped again. And finally, we shipped for real. So the lesson is when you think you're done, you're not done. Also, be careful with feature flags because they can be tricky. Unification took like 8 years, but there were some times when like basically nobody was working on it, so it's not as bad as it sounds, but still a long time. There were all kinds of crazy bugs. There were scaling bugs where like you'd try to scroll here, but end up scrolling over there because the hit test didn't account for the device pixel ratio. There were like shadow DOM bugs, so you couldn't scroll text input controls. There were even race conditions in the tile manager, which weren't even related to scrolling, except that unification like caused some subtle timing changes that tickled this pre-existing bug, and it was super hard to track down. Interestingly, there were things that got reported as bugs, even though the old behavior wasn't guaranteed. Like developers had found hacks to force scrolling on main. So they were breaking threaded scrolling on purpose in order to have like synchronized JavaScript effects, and those hacks don't work anymore. What all these issues illustrate is that scrolling is fundamentally linked to a huge set of features and behavior that have been built into the system over time. And when you try to like swap out the engine while the plane is in flight, everything that scrolling touches is a potential source of breakage. This problem is sort of endemic to all large-scale refactorings. This is the second time in my career that I've overhauled Chrome scrolling architecture, and probably the last, but who knows what the future holds. Now that unification is shipped, we're doing my favorite part, which is getting rid of all of the old main thread scrolling code. So we've deleted almost 6,000 lines of code already, and there's still a bit more to go, I think. And we're already seeing velocity improvements from unified scrolling. I was working on some new scroll snap stuff recently, and I only had to do it once. That's amazing, right? Because before, every scrolling change, you had to do it twice. Do it for the main thread here, and then do it for the compositor thread over there. But now we can get things done twice as fast. In conclusion, code health matters. Also, sometimes things take a long time, and it seems like you're never going to finish, but you just have to keep going, and eventually you reach the end.
All right. Next up, Jose de Pina Paz.
Okay, this is a new edition, like 4 or 5 times I do this, of how GCC is working. So the official Chromium toolchain is using LLVM for a long time already. It's Clang compiler and leaves C++ as the C++ standard library implementation. No other toolchain is supported officially in Linux. But we still have people using GCC, live standard C++, that are the GNU project implementation. Variety of reasons. maybe some hardware support, backwards compatibility. Yeah, many reasons. The recommendation, again, is please, if you can, move to Clang and leave C++. There are many nice things in the new toolchain. Yeah, that's great. These basically are the two ways to do that. But two ways, no. Two things that you usually need to do. Maybe building the C++ dependencies with leave C++, or move everything to leave C++ and Clang. But meanwhile, okay, this still maintains, it's still working. GCC and leave standard C++ are ready to use and are ready for you. Okay, this is the chart of the GCC status, the backtracking the effort. We see that in this year, there was almost no bug in this site. It's interesting because it's less effort, that's nice, but yeah, the usual problems these couple of years, it's classes with variables, constructors that are ambiguous in the interpretation in GCC, constant expressions, no except, intrinsics. Casting is different in GCC. It's not allowed to be implicit. Yeah, template specialization forbidden in. Okay, leave standard C++ is still a lot of work. Yeah, main problem basically is missing includes because the regular headers that you are going to get in leave C++ include more stuff. So usually you need to add more in leave standard C++. STL containers do not allow consts as the contain type. Yeah, a unique pointer assigned to for a new pointer requires a destructor, so you actually need to include the headers. Okay, the status, we have this Jocto recipe you want to try on embedded devices. Targeted runner Raspberry Pi 4. Yeah, you can try it, it's up to date. And yeah, the credits for this year, these are the people that collaborated more. Please. And that's it.
Next up, Dominic Roches.
Hello, I'm here to talk to you about Chromium's upcoming Rust font stack. In October 2020, something caught our attention. Sergey Glazunov from Google's Project Zero found a security bug in FreeType. FreeType is the library that we're using for font processing. The issue was quite severe. It was actively exploited, and these days on GitHub, you can find the exploit code if you look for it. So we wanted to look closer. What happened there with FreeType? And in the course of 2 years, we found 4 CVEs, 6 P1, P0 issues, and a high number of cluster fuzz and OSS fuzz issues. Each time they require analysis and fixing and backporting to Chrome Beta and stable. And in some cases, these affect Android as well. How much are we exposed to this in Chrome? We are exposed to it on every platform because we're not using FreeType only on Linux and Chrome OS and Android, but we're also using it on Windows and macOS when we need support for a particular font format that the system rasterizer doesn't do. So we're exposed to it everywhere. What do we do about it? How do we fix this? We reached the FreeType code through an API called SK Typeface. And SK Typeface has several backends, and the most common one here is FreeType. And here's where we add a Rust library. The library is called Fontations. It's maintained and written by Google Fonts, and we're integrating it into Chrome through the SK Typeface API by making an extra backend. Fontations consists of mostly these 3 libraries: font types, read fonts, and Scrifa. Font types is the basic types, read fonts is parsing, and Scrifa is higher level functionality. If you're interested to learn more about this, come to the session at 1:50 today. Thank you.
Okay, 1 second while I load up the next one. Okay, I'm gonna change. There you go.
Okay, thank you. Hi, I'm Max, and let's talk about interactive UI tests on Wayland. First, some background. Interactive UI tests uses the functions defined in the UI controls header to generate mouse and keyboard events. But on Wayland, it's prevented that clients generate events themselves. But Wayland does allow protocol extensions. And so the Western compositor created the Western test extension for their internal test suite, which allows clients to request the compositor to generate events for them. And Chromium tweaked this a bit and then reused it. But there's some problems with this because it was created for a completely different purpose. So it maps quite poorly to the UI control semantics. And also the implementation uses run loops, which can interfere with the D&D implementation and cause deadlocks. And in practice, this meant that a lot of tests were failing or flaky on platforms that were using Wayland. Many of them D&D related, for example, most of the tab dragging tests, and we had to disable a lot of tests, which is bad, of course. So we wanted to fix this by designing our own custom protocol extension, which has a very creative name, as you can see. The intention is that it has almost the same semantics as all the functions in the UI controls header. And to achieve this, we have one protocol request per function in the header, plus an additional request processed event that the compositor can send back to the client to tell it that it has finished processing the request. And this needs no run loops in its implementation, which is very nice. And it works quite well already. Together with some other changes, we were able to reduce the number of disabled tests significantly, as you can see here. But there are still some problems that need to be fixed. We are already working on fixing a race condition that is still causing problems with drag and drop tests on Lacrosse. And on Linux, we had to find a way to resize and move the browser because the tab dragging tests were relying on that. But as you can see, it's already crossed out because just 2 weeks ago, we merged a working solution for this. Let's see if we can get this to work. Yeah. The basic idea is to just simulate the same interactions that a regular user would do to move and resize the browser. And it works quite well, as you can see. If you want some additional context, here are some links. And that's it from me. Thanks. And thanks to these people for the help.
All right, next up, Rob Pavesa.
All right, thank you very much. Yes, I'm Rob Pavesa. I'm an engineering manager at Microsoft on the DevTools team. This is my first BlinkOn. I'm a little scared of the gong. And I want to talk to you a little bit about what we're working on, which is standalone DevTools traces. And so first you might ask, well, what's a trace? And obviously we have the Chromium tracing infrastructure where we're able to add events and get an idea about where am I spending CPU, why am I dropping frames, things like that. But we're also interested in being able to figure out where's my memory going. So we're thinking about this in terms not only just of the Chromium tracing infrastructure, but also in the heap snapshot and things like that inside of VA. And so obviously traces can come from DevTools. We get the buttons and all of that stuff, but we also can originate traces inside of DevTools protocol. So you fire off a tracing session or you take a heap snapshot or something like that. What we find is that a lot of our partner teams are interested in capturing this information in a way that can be automated. And so you might get it out of a Puppeteer session, you might get it out of Playwright, you might get it just out of embedding a web view inside of your application and being able to fire that off individually when a user reports a problem. So what does it mean to be standalone? Well, we're really interested in making sure that DevTools can load a trace and make it be usable. So one of the problems that we have with exporting and then importing a trace inside of DevTools today is that everything is kind of related to script ID. So if you're looking at call stacks, those are going to be mapped back to script ID. Heap objects inside of your heap snapshot are going to be based on where script ID. And the problem is that script IDs are ephemeral per renderer. And so every time you change a process, or if you don't repro your process in exactly the right way, your script IDs can be off. And in the best case, you just don't get a link back to the script. And so it's really difficult to go back and try to drill into what the root cause is. We want an exported trace from whatever this is to be able to be used without needing to execute the repro scenario. So the browser had all of the context that was necessary at the time that the scenario was executed. So can we capture that information? And so how do we get there? And so we're looking at a couple of things about prior art. Obviously, Windows Performance Analyzer has this ability that when you attach, you can start getting source rundown events from V8. And WPA can use these to map these data to memory locations for JavaScript functions, which is pretty good, but WPA, you have to know what you're doing to use WPA, I think. And then we've also been working on this internally on Edge to call it a DevTools snapshot. So upon completion of a scenario, you can take a snapshot, and this kind of gets you enough information. It works very well for single frame targets, but it turns out that there are a lot of applications that are not single frame targets and in fact use multi-process pages. And so it's not particularly adequate for us. So coming soon, and this has been an ongoing discussion on DevTools Dev. Oh, see, hit the gong. Thanks very much.
Next up, please welcome Sunshine.
Hi, I'm going to present the current status of cloud gaming by NVIDIA. I hope many of you may play the cloud gaming as of today, but cloud gaming is very simple. Like there is server in the cloud, and there is game engine, and the actual streaming is coming through the encoder and decoder of the device. That is the very simple diagram of the cloud gaming. And one of the main characteristics we are thinking about the cloud gaming is the latency. How we can reduce the latency is one of the major part of the cloud gaming. And a lot of companies are working very hard to reduce this latency. And as you can see, there is a latency from the client to the server and again back to the client. So there is a controlling part like cloud game server and client device. There is an uncontrolled part like network, like latency from client to the server and server to the client is kind of a very hard problem. So I want to share what is the current status. So this is actual data from the 4K 120 frame. From the device, we are closely working together with Google team. And this is the data I want to show you is the small delta between that is the data from different video frame, that is 5 milliseconds. And another big delta is coming from the missing packet and how it can be recovered, how soon it can be recovered. It's 10 milliseconds. So this is measured in actual device and actual network. So it's quite good in normal condition. But in bad condition, we have to solve a lot of problems. So I think there's some differences between normal video streaming, but the most important thing is the latency and providing the stable video and reducing or consistent latency. And what we are doing now is to providing a higher resolution of video and enhance latency with a higher frame rate. Just I share 120 hertz is kind of helping the latency. But now we are focusing on quality improvement over the bad network. One of the things we are now doing is doing the non-keep frame recovery on a bad network condition. And another thing is to make a consistent latency. For the gaming, the consistent latency is more important. That's it.
All right, up next, Francis McCabe.
Thank you. So today I'm going to talk to you about running asynchronous WebAssembly using JSPI. So we all know that the web is an asynchronous platform. You know, there's all those promises, somewhat pesky promises. For example, fetch. However, it's also true that it's not just the web. This is a general trend in the industry as a whole. So the POSIX AIO star APIs, and if you're building a robot, you also need to be reactive. On the other hand, if you write C code, then you're used to writing synchronous code. And remember that WebAssembly up today is there to allow you to run C code on the web. So it's kind of unusual. So it's not just the applications, also the libraries that are oriented to synchronous APIs. And this represents a mismatch, an impedance mismatch. So, and you can deal this yourself in C if you manage promises, but that is kind of difficult to do. And there is a technique at the moment, if you're using WebAssembly, called Asyncify, which liberates you from this difficulty. However, it's expensive. It's 2 to 3 times your code size and 2 to 10 times your performance cost, depending on what you're doing. So what is JavaScript promise integration? It's a long title. First of all, it's a W3C standard in process. What it allows you to do is take a WebAssembly module and which does not offer or use asynchronous APIs, and allow it to use and offer asynchronous APIs. It's that kind of magic glue. How does it work? When you have an import, when you call an API function that returned a promise, then your code will suspend. And when the promise is finally resolved, then your code starts again. And also your application will return a promise. So you use promises and you give promises. Internally, what happens is that your code will be run on a separate stack. So this is kind of challenging within V8. When you start your code, it forks off into a different stack, and then will run again. And when you suspend, you go back to the original stack, and so on. I don't think we want an update. Okay, how do you use it? Today, this is experimental. It's available in Chrome on 64-bit platforms. By the end of this year, we hope that it will be available on all platforms in Chrome, and there will be an origin trial. But if you want to use it today, then you have to turn on some flags.
Next up, Joey Arhar.
All right, hey everyone, my name is Joey, and today I'm going to talk about top layer animations. So the top layer is this cool feature that the browser has that lets you render an element on top of all the other elements in the web page. And so like this is supported by the dialog element and the popover attribute. And so the goal here was to make these elements animatable when they enter and exit the top layer. So you can see in this little video down there, this is like the goal we're trying to accomplish. Click open dialog, and the dialog enters the top layer with this nice animation. You close it, and it has an exit animation that's nice and smooth. Unfortunately, there's a bunch of issues with this that we had to get through to make it work. The first thing for entry animations is that animating from display none doesn't work well. So like when the dialog is closed and you click open, it goes from display none to display block. And then you can see there's 2 style rules here. We want the opacity 0 to transition to opacity 1, but it doesn't actually work because the animation system never gets to see this first style rule that says opacity 0, because during that time it's also display none and it kind of blows away all those rules. So we just are left with opacity 1. And to fix this, we added a new rule called starting style. So you can see we moved the opacity 0 from the first rule to the second one. And now the animation system knows, like, okay, when the dialog opens, I'm going to start with opacity 0. And then we also have the transition opacity, and it's going to make a transition for opacity. And the next issue is with exit animations. So there's 2 problems here. One is that the display property didn't support animation, and that we also can't transition discrete properties like display. So basically what happens is, like, when you close the dialog, the browser immediately makes it display none. But we want to, like, say, like, okay, hold on, I want you to keep it display block for a little while we, animate it out, and then remove, like, put it back to display none. And then on top of that, discrete properties like display are not, like, transitionable, and you can't put them in a transition statement. So we added a shorthand to transition called allow discrete. And by adding this and also making display animatable, you can now just have it all in one transition, like this rule right here. So we have display 1 second, allow discrete, and this basically asks the animation system to, like, keep display block while we do this opacity transition alongside of it. And then we have an exit animation. The next issue is if you have multiple things interacting in the top layer, the animation, when it exits, it'll remove it from the top layer immediately. But, like display, want to say, like, hold on, I want you to keep this thing in the top layer for me while I'm animating. So you can see in this little video here, we have popover 2 that's on top of popover 1. But as soon as we do our exit animation, it, like, goes underneath the second one because it left the top layer immediately. And so to control this behavior, we added a new CSS property called overlay, which is like display a discrete property. And by just asking the transition system to transition it like this with the overlay 1 second allow discrete, it allows it to stay in the top layer while it's animating out. Thank you. It's in 117.
Thank you. Up next, Kevin Babbitt.
Hi, I'm Kevin Babbitt from the Microsoft Edge team. I'm here to talk about an experiment we're running around expanding the size of oil pan caged heap. This experiment was born out of an investigation into renderer out of memory or crashes. We had some user reports of users accessing large web pages that were failing to load and throwing an out of memory error. We also had reports from heavy Office Online users, for example, losing many tabs at once, which we think may be related to render process reuse. When we looked at our data, we noticed an interesting pattern. In about 6% of renderer we were throwing an out-of-memory error because the oil pan heap was exhausted, but the device still had plenty of commit available, which led to the question, could we raise the limit on the oil pan heap in order to take advantage of the memory that's available on the device? Now, the oil pan heap is currently limited to 4 gigabytes, and this is in order to support pointer compression, where we represent the 64-bit address to an oil pan object in 32 bits of space. You'll notice I've represented a 1-bit shift here when we store the compressed pointer. That top bit does 2 things for us. It tells us that it's a valid pointer and not null, and it also sets up a fast pointer decompression algorithm. Now, since we only have 32 bits of space to store a pointer to a compressed pointer, that would limit us to 4 gigabytes of addressable space on the oil pan heap. However, we also know that oil pan objects are always allocated on 8-byte boundaries. So what this means is that the bottom 3 bits are always 0. So instead of a 32-bit offset into the heap, we could be storing a 34-bit offset by increasing the shift from 1 bit to 3 bits. So the current state of this project, we've implemented support for the expanded cages in Chromium in the V8 repository. We've started an experiment on the Edge team to see how well these changes are helping users. It's still running. I can share in the early data, we've seen some encouraging results on Windows devices with 16 gigs of available RAM. We're seeing potentially a 20% reduction in the number of these devices that are experiencing renderer ohms. However, since I've written this slide, I have also seen one other effect, which is an increase in renderer processes that are being killed by the sandbox. Obviously, that will need to be investigated and understood before we're ready to make a recommendation to the Chromium community on what we should ship. But I mean, even if the project doesn't pan out, there were some nice code hygiene improvements that we were able to make. I'm always happy to see some improvements land, eliminating magic numbers and consolidating unnecessary code. So that's all I have. Thank you.
Up next, please welcome Junhyung Hwang.
Hello, I'm Junhyung Hwang from LG Electronics. I'm going to talk about how downstream effort to rebase to upstream. Here, the downstream is LG Electronics WebOS, web engine. And I'm going to share our experience focusing on our new strategy. WebOS is a software platform built for smart and connected devices. As the name suggests, it supports web applications, and many of them are essential apps. So I think WebOS can be a good showcase of what web can do. To this end, we provide web runtimes and web engines based on Chromium. We are developing LG Electronics Common Web Engine, WebOS reference platform web engines, and deployment or product-specific web engines. We need to upgrade to support apps. If, for example, if an app depends on API, we need provided API. I think that such apps can be good use cases of the required capabilities, because we do not know what our customer will want to use in advance. Upgrading to the latest version is our best bet. We can also provide better security, such as site isolation, sandbox, by upgrading. So we want to speed our upgrading. So we are changing our upgrade strategy from rebasing based to merging based. When we are upgrading, we apply changes, we resolve conflicts, we fix build errors, and fix runtime errors. In our previous strategy, rebasing based one, we cherry picked each of downstream patches to upstream and fix it. And when we are upgrading to another version, we repeated everything from scratch. In our current strategy, merging based on, we make a merge commit and fix resolve conflicts, fix errors. We are not handling downstream patches individually, and we do not work from scratch. So in merging strategy, the downstream branch is connected, not divided. The main advantage is we only have to deal with changes from upstream. So we are making releases more open, and we are reducing the gap between upstream and downstream. So we are trying to do things even better. So we are refactoring code to reduce conflicts, and we are sending patches to upstream so that everyone shares the same code. And we are also trying to automate tests to detect regression more quickly. Thank you for listening.
One moment while I set up the next slides. Okay, do you have speaker notes? Yeah, speaker. Okay. All right, here's Andre Botella.
Hi, I will be talking briefly about some updates from the last year Lightning talk on LineClamp. WebKit LineClamp is a property that lets you clamp the number of lines of an element, except what it does is actually it overflows those lines. You need overflow hidden to not have them render. If we're going to replace this, we want a replacement to also have height-based clamping, where it computes the number of lines automatically based on the height. There are a couple CSSWG proposals about this. Like line clamp without the prefix would be a shorthand property, and would support height clamping. No lines will be shown after the clamp point. And there are two competing proposals. Continue collapse lays out the clamp lines without painting them. Continue discard does not lay them out with fragmentation. Both proposals need to be specified in detail and prototype before deciding on one, and we actually have working prototypes in Blink for both of them with CLs. For continuous collapse, our implementation builds on the existing WebKit line clamp machinery, especially for the height, and any line fragments and block children after the clamp point are laid out and they overflow, but they're hidden from pane. There are some opinions about appspose and float. Since the clamp lines overflow, they still take scroll space, which is not great. Continuous discard is completely different. It's based on fragmentation, same as for pagination, for multi-column, and only the first fragment is laid out and rendered using something that we're calling discarding fragmentation. Layer ng pauses the layout at the end of a fragment and then resumes at the start of the next. Discarding fragmentation would not resume it. Some layer boxes would be not laid out at all. Some would be half discarded. Blink's layer engine has many assertions to make sure that the layer boxes are laid out and painted when they actually should. And discarding fragmentation hits those assertions because the last fragment can resume. Like there's content to resume after the last fragment. We're clearing the needs layer and paint flags for all of the half and full discarded boxes. This is problematic. We're only clearing them if the box is fully discarded or after laying out and painting the last non-discarded fragment. Since discarded content does not produce ng physical fragments, there's nothing to use after free. So we think this is safe, but it's not clear that this is the best solution. There are also issues where fragmentation might not be the best idea here. Fragmentation avoids breaking after the first line up before the last line, so the last two lines clamp together. So before we can settle on either proposal, we need some further spec work and work compass assessment. So maybe we should try to prototype both and see what happens.
Thank you. Again, one moment while I get the next slides together. All right, Panos.
Thank you. Hi, everyone. I'm Panos Estefas from the Chrome Web Platform team. In the next 3 minutes, I will be telling you 3 things that happen in web platform tests since the last BlinkOn. Number one, Google Summer of Code project from our awesome contributor, Rachel Russell. This was about improving the test history view. If you have not seen that, it is accessed through a show history button underneath the single test view test results. And then it used to take you to this old view, which, as you can see, is quite dense, not super intuitive, hard to parse out how things work there. But we replaced it with a more traditional timeline view, where you can see results over time of the specific test and how the test status change from failing to passing and vice versa. You can observe whether the test has been flaky, and you can also interact with it. If you hover over the point of interest, it shows you the test status and the test run code, the test run date, I'm sorry. And then clicking that section will take you to the full results of the test run that affected, so you can debug perhaps the problem and figure out why it happened. Number two, if you are tired of waiting for Chrome Dev to update or you're interested in results for Chromium browser, then Chromium Nightly results are the thing for you. It gives you access to results on the latest landed code on the repository. It's searchable as a separate product, so search for Chromium instead of Chrome, and you can use the nightly label as normal. Chrome Canary results will follow soon. Number three, a number of reliability improvements to make interacting with web platform tests easier for you. The aim was to arrive to fewer failed checks when your PR gets to merge, fewer missing results, especially on Safari, and fewer errors when you're searching due to improved search query support. Notably, the Chrome stability checks are now no longer blocking your PRs, so you should no longer have to worry about that. And things that are coming soon in the last few seconds, we're working to making sure that April 2024 can include mobile browser testing. So Chrome on Android and Firefox on Android are very close to getting there. We have a few roadblocks with Azure infrastructure support for doing the same on iOS, but we expect in the next few months we'll get there. If you, by any chance, work for Microsoft, please come find me. I want to talk to you. And that's all I had. Thank you.
All right, 1 second again. I got an access denied. Oh no. All right, Weizhong, they run. All right, your slides are access denied. They weren't shared with us. So, yeah. What? I mean, I pull it up and it's not shared with Victor. 1 second, everyone. Okay, let's do that. Panos, are you ready to do your second one? All right. All right. Let's go, Panos.
All right. It's me again. This time to tell you 3 things that happened in Origin trials since the last BlinkOn. Number 1, better integration with Chrome status. As a team, we are in a multi-year journey to fully integrate all the systems related to launching features and experimenting in Chromium. Since the last BlinkOn, we made progress on a few of these pieces. Number 1 was make it easier to switch between the 2 systems, the Origin Trial Console and the Chrome Status tool. So if there was already a way to visit a feature in Chrome Status from the Origin Trial Console, now we added a way to go to the other direction too. This paved the way for adding a new request trial creation button in Chrome Status as well. So there's no longer a need to consult the documentation about the next steps after your intent to experiment has been approved. The Chrome Status tool provides the action button, and then the interstitial dialog that comes up highlights the key requirements for a trial creation that you should be mindful of. And if you click proceed on that, it will take you to an ingestion form that used to be a separate page served under Google Forms. Now it resides in the same tool, stores information in the same place, and it provides us more opportunities in the future to more seamlessly integrate the 2 systems, as I'll show you in a second. Number 2, the registrants dashboard. This is another workflow we automated. It is about reviewing registrations for your trial. This was something that feature owners had to contact the Origin trial admins for, and we had to manually collect that information and share it with you in files and then clean all that up. Today, we have a self-service dashboard that you can use at any point in time after your trial begins. It looks like this. There's a section with the details of each registration that you receive, a trend line of historical registrations, over time, and then a few breakdown charts across a few axes like usage scale and whether a third-party origin was requested. We only have privacy approval to make this available to Google employees, so if you don't work for Google, reach out to your Chrome contact and they will be able to sort you out. Number 3, a few implementation updates. So one important thing to call out is that we are working to remove the requirements to submit feedback in order for your token to remain valid. This has been a constant sore point for participating in trials. And WebView is now a supported platform, so please take that into consideration as you're planning your experiments. And we now allow origins in the public suffix list for deprecation trials. Things that are coming soon are generally full automation of the pipeline, and we hope you will be able to show that next time. Thank you.
All right, please welcome Weizhong.
Hi, my name is Weizong, and I'm from BlinkOn Enterprise from Google. On BlinkOn 17, I talked about our plan for the WPT in Chromium project. Today, I'm going to give an update on the progress and our plan for the next step. So, summary of the status. Well, we worked on improving run WPT test toward feature parity with run web test. We also spent time to reduce the total test time when running test with run WP test. In early September, we launched a pilot program, ask developers to give a try on the run WP test and give us feedbacks. We are now working on addressing those feedbacks. So what we did, first, we're trying to reuse the test selecting and the sharding algorithms from run web test side. Doing this automatically makes a lot of features available in run web test now available in run WP test. So for example, where the exclusive tests configuration and the platform configuration from virtual test suites continue to work. Test skipped through test expectations will still be skipped. The different ways to speech about tests list will also work on run WP test. Also, developers can continue to use those tricks to speech about tests from command line. For example, run WP test.py -- release third-party Blink web test blah blah test name will still work. Also, with made support for virtual test in WPT Runner. This is built on top of WPT Runner's substitute concept. Here's the link to the RFC. Virtual test will present the same way as before in logs and result.html, which is virtual prefix and then base test name. Another feedback we get from developers is that we want to continue to use test expectation in the baselines in the new system because WPT metadata is kind of complicated. And also the baselines, how test fails matters, and the baselines will specify how test fails. And what we are going to do is to make change to make baselines make it possible, and then we will convert test expectations and the baselines to WPT metadata on the fly. CI. So the CI modules are now shared between run web test and run WPT test. So this is mostly the same, except for those things that definitely need to be cannot be the same. So yeah, these are mostly the same. And then for performance, will reduce the total test time from previously 3 times slower compared to kernel shell to now 20% slower than kernel shell. What we did, we used a final grouping algorithm to reduce workload imbalance between workers. Also, we removed a blocking waiting point when running different test types. Previously, we have to wait for one type of test to finish completely to start testing a new test types. Also, we are working on reduce the overheads when using run WP tests. Next step. So we're going to add the Linux WPT Chromium layer to CRCQ soon. And we can possibly upload the results from this builder to WPT FOI to get the fresh results for Chrome. And the next step, we are going to fix the CTP related issue in kernel shell and then start to run WPTs with content shell through a Chrome driver. And this is how it will look in the end. So in future, legacy layout tests will run with run web test, and with Blink tool, the baseline shell and the test expectations to create a baseline and test the expectations. And then for kernel shell, thank you. Yeah.
Thank you, Ben. Okay, now to close us off, we're gonna hand you back off to Kentaro. Let me just repin you.
So,
Go ahead.
yes, so thank you very much for many amazing updates and heartwarming messages. So I am so excited, so because we have many speakers from multiple organizations, including Inaria, so NVIDIA, Microsoft, and many non-Google speakers. So please send another round of applause to all the speakers. So thank you very much. And if you are interested in some specific topics, so please directly reach out to the speakers. So please do that. So great. So I think that's it for today. So we will have another lightning talk session tomorrow. So see you tomorrow. So thank you very much.